Hey guys, welcome to your channel DNA. In the part 2, we have created VPCs. Each VPC we have created subnets, right? In the part 3, we have created the VM instances. We have two instances having a two NICs. We have one more instances. We have three instances having a single NIC belongs to the different VPCs and the different subnets. Now let's verify the connectivity between the VMs. How to verify? There are two ways to verify. Number one, through ping or through SSH. Okay, so before let's cross verify the IP addresses automatically assigned by the GCP DHCP server. Okay, so let's log into the VM. Perfect. So what's the VM? US VM1. Go to the US VM1. Right, you can see the NIC 0 IP address 10.1.1.2. Yes, it is there 10.1.1.2. You cannot see the NIC 1 IP address over here. You have to go to the VM instance. Inside the VM instance, when you click on the network setting, here you can go, you can see the NIC 1 IP address 10.2.1.2. 10.2.1.2. So it's very lengthy process, right guys? Every time you have to click on the VM instance, then go to the network setting, and then you can look at the IP address. The better way, use the CLI, right? So go to the Cloud Shell, right? Once you enter into the Cloud Shell, execute the command gcloud compute instance list. You will see all the instances belongs to this project name as a DNA GCP cloud project, and you will see the primary IP address and the second, not I can say secondary IP address, NIC 0 IP address and NIC 1 IP address. So the command is, so let's maximize so that you can see better. Okay, so execute the command gcloud compute instances list. So this command will show you the IP addresses of instance. See, now look at the US VM1. US VM1, where is the US VM1? US VM1 having a NIC 0, NIC 1, 10.1.1.2. The first IP address is always a NIC 0 IP address, and second IP address is a NIC 1 IP address, so 10.2.1. Then US VM2, US VM2 10.2.1.3, 10.2.1.3. Perfect. This is the IP address. Then US VM3 10.2.2.2, 10.2.2.2. Perfect. Then Europe having a primary IP address, NIC 0 IP address 10.1.12.2, 10.1.12.2. Perfect. And 10.2.11.2, 10.2.11.2. Perfectly fine. Right. And the US Europe is Europe Central 2 machine 10.2.12.2, 10.2.12.2. Perfect. So I have captured all the correct IP address in my diagram. Okay, so let's get start and initiate the ping. Now by default, whenever DHCP server assign the IP address to any machine, any VM, by default route is pointing towards the NIC 0. Perfect. Irrespective of NIC 0 connected to which VPC, whether it is connected to VPC 1, VPC 2, doesn't matter. Now tell me, example US VM3, it is connected to VPC 2, NIC 0. Now you have a default route pointing towards the NIC 0, because this US VM3 has only single NIC. But what about this US VM1 instance? What about this? Yes, of course, default route is pointing towards the NIC 0. And what about the NIC 1 then? No. NIC 1 can ping the IP address belongs to its connected subnetworks. That's it. When I say connected means 10.2.1.3 is a connected subnet. But PD, we have another subnet over here in the VPC2. No, you cannot ping this subnetwork. Why? because it's not directly connected. It's a 10.2.2.0/24 and it's a 10.2.1.0/24. Right? Got it? So let's do one thing. First, try to ping the IP address within the VPC. Of course, within the VPC, definitely you can ping the IP addresses. But between the VPC, you cannot. Why? The reason behind it, VPC never share this subnet by default. You have to enable VPC sharing or VPC peering. Then only you will see the cross VPC routes. Clear? Okay, let's move on. Log into the US VM01. Log into the US 01 VS VM01, right? SSH the device VM1. Once you click on SSH, your browser will connect automatically to US VM1 machine. Here you go. Now you have a SSH access to US VM1. In our diagram, this one, US VM1. Now do one thing, try to ping the Europe VM1 NIC0 IP address, which is 10.1.12.2. Okay, perfect. Ping 10.1.12.2. Yes, we can able to ping 10.1.12.2, which is the IP address of Europe instance NIC0. NIC0 is connected to VPC1. Similar way, US VM1 NIC0 also connected to VPC1. That is the reason VPC to VPC connection by default is allowed. Do one thing, can you please try and ping Europe VM1 NIC1, which is connected to the different VPC network? Yes, let's go and ping. Ping, what's the IP address? 10.2.11.2. 10.2.11.2. No, you cannot. Why? The reason behind it, because this VM has a default route towards the NIC0. It's a default behavior. That is the reason you are not able to ping this IP address. Second, this NIC1 is connected to VPC network 2, and this subnet 10.2.11.2 subnet, or I can say subnetwork 10.2.11.0 is belongs to the VPC2. So route for 10.2.11.0 is not at all available here in the VPC network 1. That is the reason you won't able to ping NIC1 IP address. Clear? Okay. Then do one thing. Can you try and ping the IP address of the VPC2 US VM2 NIC0, because this machine, this NIC and this NIC belongs to the same subnet. Okay, let's go and try. What will the destination IP from US VM1? Let's try to ping US VM2 NIC0 IP address, which is connected to the VPC2. Okay, let's go. So ping 10.2.1.3. Here you go. You can. Why? Because these NIC1 and VM US VM2 NIC0 IP address belongs to the same subnet and both interfaces are connected to the same VPC network. Now we have one more machine in VPC2 within the same region US Central 1, but having in the different subnetwork. So can we try and ping NIC1 from NIC1? Can we try 10.2.2.2, which is connected to the different subnetwork but belongs to the same VPC? Okay, let's go and try it. Ping, you won't able to ping 10.2.2.2. Why? The reason behind it, the default behavior because of the default behavior. NIC 0, NIC 1, whenever the packet is not in the same subnet, it will be route towards the default route, which is towards the NIC 0. So 10.2.2.2 destination and source 10.2.1.2, which is not belongs to the same subnet. Hence, US VM1 will send all the traffic towards the NIC 1. Oh, okay. Now, what was happen and why it this VM US VM2 NIC was pinged? The reason behind it, these two are in the same subnet. So for VM1, it is directly connected, but for US VM1, this 10.2.2 is indirectly connected. So it will send traffic over the default route. Clear? So these are the default behaviors. Okay, do one thing then. Can you please log into the US VM2 and try to ping US VM3? Yes, yes, definitely you can. Why? Because this VM instance is connected to only VPC network 2. US VM3 also connected to the VPC network 2. Hence, they will able to ping each other. Right? Next, VM US VM2 having a default route towards NIC 0. VM3 US VM3 also having a default route towards NIC 0. So definitely both VMs have a default route towards the NIC 0, which is in the VPC network 2. So definitely you can able to ping these two machines, this one and this one. Clear? Okay. So log into the US VM02. US VM02 SSH. Once you do SSH, then it will go to the browser and try to connect your machine. Yeah, here you go. Now you have access to US VM2. Okay. So sudo first check your IP address, IP config. Yes, my IP address is 10.2.1.3. Absolutely correct. 10.2.1.3. Now try to ping 10.2.2.2, which is belongs to the different subnet. Okay. So ping 10.2.2.2. Yes, here you go. You can able to ping 10.2.2.2. Now try to ping 10.2.2.1, which is a US VM1 NIC1 IP address. Definitely you can. The reason behind it is NIC0 of VM2 and NIC1 of VM1 within the same network. Definitely they can able to ping each other. 10.2.1.2. Yes, correct. Now go ahead and try to ping NIC0 IP address. NIC0 IP address. No, you won't able to ping. Why? Because default route is pointing towards the NIC0. When VPC2 network router will receive the destination IP 10.1.1.2, VPC network 2 doesn't have route to reach 10.1.1.2. Why? Because the 10.1.1.2 it belongs to the VPC network 1. Clear? Right? So let's go and try. Ping 10.1.1.2. No, you cannot. Right? Now what happened? As soon as you hit enter, so what will happen? Packet has been generated and set it towards the NIC0. Right? So your VPC receive the packet where your destination is 10.1.1.2. Then VPC to look for the how to reach 10.1.1.2. VPC doesn't have any route. Why? Because 10.1.1.2 is configured under VPC network network 1. Clear? Right? So yes, these are the I cannot say issue. This is the default behavior that VPC has. So what are the solution? There are different kind of solution. One, you can manipulate the instance routes, right? Local routing table. right? Because it's a Linux. Definitely you can, right? Second, you can enable the VPC sharing, and the third option is you can enable the VPC peering, right? Last but not the least, policy based routing. You can enable policy based routing on your VM instances. So, but to be honest, to influence the instance routes is very difficult. If you have a 2, 3, 4 up to 5 instances, I don't think there will be the problem. But if you have the 50, 60 or 100 plus instances, it is very difficult to maintain the routing table, right, of each instances. Better way, we have a solution. Pair these two VPCs, so that what will happen? These two VPC will share their subnet with each other. Of course, you have to allow the firewall rule as well. Clear? Thank you so much for watching this video. For detailed solution how we can reach cross VPC subnet, for that please refer my next video. Thank you so much.